my little love buttons. We are working on day 8, talking about equations and inequalities, now dealing with logs. So as the start bell rings, we're ready for class. I would like you to try example 1, 2, 3, and 4 as a quick warm-up problem. I'm going to have you pause the video and see how you do. Let's see how you did. So most of these are review, actually all these are review. Number 4 was actually from our day 7 notes, so hopefully that came back to you. But for all of these, you're going to do whatever you need to get x by itself. Usually that means apply log to both sides or ln to both sides. Use your calculator when you approximate and make sure you close your parentheses. If you got any of these wrong, please go back, find your mistake, as this is review. Moving on a little bit, we're going to solve an equation where the unknown is in the exponent. So for this one, gotta readjust everything here. We're going to find all real number roots of the equation. 4x equals 3 raised to the 2x plus 1. So we've done one similar to this in our last notes. We're going to do the exact same steps by getting x in front, which means apply log to both sides. You'll have the x, jump in front when you take the log of 4, and you'll have the group 2x plus 1 jump to the front when you take the log of 3. Again, this is one of our properties from our red log property sheet. Our goal is to get x by itself. So what I'm going to do is actually distribute here and get all the x's to one side. So nothing changes on the left for right now. Over here you're going to have 2x log of 3 plus log of 3. I'm going to move my x's to the left, so this x log of 4 stays. I'm going to subtract over 2x log of 3, and what's left over is just a log of 3. I'm going to factor out an x using the GCF property. And now I'm going to undo the multiplication here by dividing. So I'm going to get x equals log of 3 divided by log of 4 minus 2 log of 3. This would be the exact answer if you typed it into your calculator, which you should practice typing in right now. You will get negative 1.355. If you did not get this answer, make sure you have parentheses after your logs. Make sure the denominator is log 4 minus 2 log of 3. And really make sure you can do it on your calculator. Like we did last time, we are going to compare it now to the graph. Each side is part of the graph. So 4x is a line. It's going to be a line in your calculator. It's going to still be a curve. And then the right side is going to be another y equals on your calculator. We're going to find where they cross. As you can see, they cross at negative 1.355, which is what we found as well. So what you just did is the algebraic. You can also look at it with a calculator to verify and see that those are the solutions. Okay, moving on. Let's try some more. Find all real number roots of the following equation. The hint is transform into exponential. That should always be in your mind. If you're in log or ln and you're stuck, go to exponential. If you're in exponential and you're stuck, go to log, go to ln. Okay, that really should be where we're thinking. So, part A, let's do that one together. Part A is ln, parenthesis ln of x, equals 2. Well, you need to realize that if we're going to put this into exponential, the base for ln is always e. Just like for log, the base is always 10 unless specified. So bringing it into exponential, I'm really going to have e squared equals the argument ln of x. I'm still in like ln here. I guess I can think of it again like, okay, this is the base e. We can put it into exponential again. Looks kind of weird, but you're going to have e raised to the e squared equals your argument. So you just solved for x, having to actually apply bring in exponential twice. Type this into your calculator, and you're going to get 1,618.2. So 1,618.2 would be the real number solution for this one. Okay, so don't be afraid. Use that base of e to help you out. Part B. We have e ln of x equals -2. Notice our variable is in the top. It's in the exponent. So we're in exponential. I don't know what to do. Let's go into, in this case, log. We can apply the log to both sides. Or because it has an e, my friends, this is the best idea to apply ln to both sides. So doing so, your exponent pops up front. You're given ln of e, ln of -2, and you're like, hey, this is pretty nice. ln of e is just 1, we know that. Ooh, but then you have to realize we have a negative argument. If you see this right here, you can stop and say this is not going to happen. If you don't see it, you can be going through your calculator steps like we did in the past video, and you'll get some kind of error in your calculator. Either way, I say if you see it fast, let's stop. This is going to be no solution because you cannot have a negative argument. You will not have a real number root between that curve and -2. However, let's try part C, which is very similar, e to ln of x, but this time it equals +2. I'm going to do everything I did prior. I'm going to apply the exponent to the front, apply ln to both sides. Again, notice that ln of e goes away. It's just 1. So I have ln of x equals ln of 2. We have equal logs here, or equal ln, which just means the arguments can be equal. X equals 2, and then you're done. Okay, so pretty cool properties here. Make sure you go slow enough to be able to find any no solutions or any errors that could pop up. We're now doing a little more practice. Hint, we're going to think of the shapes of the graph. So if you need help with any of these, you're thinking, oh, maybe if I graph it, where are they going to cross is what I'm thinking. So I'm going to do a couple, then I'm going to let you try some. You can see there's already a partner challenge down there, so some of you are pumped and ready. But here we go. Let's do a couple of these practice. Sorry, I don't know why it keeps doing that. Okay, so first thing, your exponents are in, your variables are in the exponents. So to get them down in front, you can apply the log to both sides or the ln. It will not matter. Okay, so I'm going to show this one with ln. It's faster to write, but it will not matter in the end. So the 2x minus 1 gets put to the front, taking the ln of 3. X gets moved to the front, taking the ln of 6. We want to get x to the same side, so I'm going to go ahead and distribute here. This looks familiar from the beginning, but now we just have ln's. It doesn't matter what side you put Your x's are what side you put your numbers. I'm going to go ahead and just put the x's on the left side. So I'm going to subtract over x, ln of 6. I'm going to add over ln of 3. GCF like we did prior. Isn't it just fun to write ln? Do you see how fun that is? Oh, gotta love it. Then you're going to do your division to undo the multiplication. This would be your exact answer. And then we are confident to use our calculator because we're going to close our parentheses, and you should get about 2.71. Problem 2. You're in log base 10, argument log base 10 of x equals 4. I'm in log. I'm stuck. Well, try exponential. Get yourself out of there. Take your base of 10, raise it to 4, and it's going to equal your argument. Still kind of stuck, so think back to what we did above. We can put it into exponential again. Take your base of 10, raise it to 10 to the 4th equals x. You by all means can put this in your calculator. You'll probably get overflow, so you are okay to leave it like this. Unless your calculator is super fancy, then you can keep going. I'm going to ask you to pause the video and try the next couple examples here. So I'll zoom out. So you have 10 in the exponent 10 log x equals -2. Yep. E to the ln of x equals 2. And then this log base 10 problem. Please try those and let's see how you do. Let's see how you did. So for the second example, well, I guess for the third example, realize you're going to put it into log on both sides, and you get a negative argument. You stop. You're done. You can't have it. For the fourth example, notice it's the exact example from above. You're going to take the ln of both sides. You have equal logs or equal ln's, so you set your arguments equal. The last example, your first step, put it into exponential. Realize then you're going to set it equal to 0 and factor. Back to the good old days. So if you got any of those wrong, please correct. We are now going to do our last problem together. It says find the x-intercept for y equals 4 times 5 raised to the 2x minus 5 raised to the x minus 5. Well, we know x-intercept means y equals 0. So my first step is to plug in 0 here. And now I need to realize 5 raised to the 2x minus 5x. I can use what's called u substitution. We talked about that a lot in previous chapters. If I call u 5x, this then lets me rewrite it as 4u squared minus u minus 5. It just makes it a little simpler to look at. Now it's just a little baby quadratic. I'm going to factor this. You can choose to split the middle. You can choose to just look and be able to see these are the two factors. Be confident in factoring. You'll need those little skills. And you'll do zero product property. U equals 5/4 and u equals -1. Don't forget, this is the only step that I'm hesitant about u substitution, is I don't want the answer in terms of u. I want you to substitute it back in. Huge step. Okay, so when you substitute in, you really get 5x equals 5/4. You can solve that. And 5x equals -1. That's something that we can solve. Okay, I'm in exponential, I'm stuck, so I'm going to apply the log or ln to both sides. It doesn't matter. So x is going to equal ln of 5/4 divided by ln of 5. If you type that in your calculator, which you should to verify, you should get 0.139. If you're looking at your second answer, the first step would be to take the ln of both sides, but realize you're going to have a negative. So this is not possible. For the same reason as above, you can't have that negative argument. Your first step would be to take the log of both sides, and then you are stuck. Okay, so we got a lot of practice in. If you want to try that partner challenge, please do so. Show me at the beginning of class, and I'll give you some extra points. With here, you actually have to apply a couple different ideas. Look at previous videos, look at previous classwork, and then we will find x. Good luck, guys. Be confident. You can do this.